Hi viewers, this is Sri Ramlu. Today's topic is water tuning fork. Okay, first tuning fork. Tuning forks are used to produce sounds with a different frequencies. Okay, so tuning forks are used to produce different sounds. So for producing the different sounds, we use tuning fork. Tuning forks are having purity of tones and suitable frequency. So when it has a suitable frequency, it cannot produce any disturbance. So that is called purity of tones. Okay. And next, a bar is bent in U shape and a stem is added at the midpoint to form tuning fork as shown in figure. See, there are generally two bars are there in the tuning fork. So these two bars. So let me take this bar and make it bend like this, and this tuning for this bar attached here. Okay, so this is called stem. Okay, like this. The frequency of tuning fork is equal to 2/3 2 by 3 of the vibrational frequency of the bar. So how much it has a frequency? So frequency of the bar among 2/3 frequency we have to take here. 2/3 frequency only for the tuning fork. Due to the presence of stem, this is due to the presence of stem, at the midpoint stiffness increases. So middle point means where from up to here, this is the middle point. Stiffness increases at the point forming antinode at the center of the center as shown in figure. So here antinodes forms. Antinodes means what? Suppose one wave is producing like this and one more stationary wave is coming. Okay, so two waves are there. So here this is minimum amplitude, that is called antinode. Minimum amplitude is called node. Maximum amplitude is called antinode. Okay, minimum amplitude is node, maximum amplitude is antinode. And here antinodes are forming here, antinodes. Okay, and this side also. Due to the presence of antinodes at the stem, here at the stem also antinodes are forming. Stem amplitude is less if the vibrating tuning fork is touched when the vibration stopped. Okay, just if you touch here, then its amplitude, what happens, it becomes amplitude decreases, but this side amplitude cannot decrease suddenly. The reason is that tuning fork loses its energy rapidly at the edges than the at the stem. Generally, when you suppose tuning fork is vibrating, if it is here, what happens? It stop rapidly, means suddenly stops. Okay, but here it's not like this. But here suddenly it stop at the end. Okay, the rate of decay of energy is small and the tuning fork continues to vibrate even if it is at the stem. Here at the stem, what rate of decay of energy means, decreasing energy is less here, is very small. Okay, when it is vibrating, tuning fork is continue to vibrate even if you touch it. Even if you touch here, it starts vibrating. But if you touch at this point, then it stops suddenly. Later it cannot vibrate. The frequency of tuning fork depends on its dimensions and the nature of the material. Nature, dimension and nature. Nature means tuning forks not only prepared with always iron like this. With a different material we can prepare it like this. So that is indicate nature. And a dimension means their size. Okay, their size, their length and thickness. If the sides of tuning fork have cylindrical shape with the radius r and a length L, then frequency F is equals to R by 1 plus L square under root Y by rho. Here Y is called Young's modulus of material, rho is called density. Okay friends, so this is about tuning fork. Don't forget.